So this session is two parts. The first part, I'll be discussing with you some analytical questions. And then the second part, your doubts and some more analytical questions by Dr. RK. And anything you feel you wanted to get it clarified, you can ask, in between. So let me share my screen. And then B80, just a second, just show. So don't play narration. So this recording, I'll post it in the YouTube channel also, so that the website can see. So can you please confirm, is the screen visible now?
Yeah, yes, sir. Yes, sir.
Yes, sir.
Yes, sir. Very good, very good. So the analytical questions. Can one of you read out the question for me so that it can be lively?
What is the area contained within -1 and +2 standard deviation of a normal curve?
What is the area contained within -1 and +2 standard deviation of a normal curve? Do you think you will be able to solve this question, all of you, all the black belts here?
Yes,
All
sir.
of you know the normal distribution, right?
Yes, sir. Yes, sir.
So I'm also drawing the normal distribution curve. I draw the center line, and this is 1 sigma from the center, 1 sigma from this side. What is the area between the two lines? 1 sigma.
68% is
Very good, 68.
68%.
So right side is how much then? 34. Am I right?
Yes, sir. 34. Yes, sir.
68.27. So this will be 34.135. Same thing will be there on the left side also. All right. So now one more sigma. If I add one more sigma, 2 sigma here, 2 sigma here, right? Now what will be the area from -2 to +2?
95.
95. Out of the 95, up to this is 68, right? So please do little max. 95.45 minus 68.27. If you do that, you will get this area. What do you call? No, let me put a small into. You will get this area and this area. All of you are following me? 95.45 minus 68.27. What is the number you are getting? 95.45 minus 68.27. Please
0.45.
work along with me. 95.45 minus 68.27. How much is the number you are getting?
27.18.
27.19.
Very good. 27.18 will divide into both sides. This right side area, 27.18 divided by 2.
13.59. 13.59.
Very good. So divided by 2 is 13.59. Let me write 13.59 here. 13.59. Now tell me what is the question once again. Question is from -1 up to
+2.
+2.
So from -1 means it starts here, -1, isn't it? From -1 to +2. What will be the area? What is the max here? 13.59.
Adding 13.59 plus 68.
Plus 34.
Very good.
34.13.
34.132 times, so 68.27. So 68.27 plus 13.59. Can you tell me, one of you, 68.27 plus 13.59?
81.85.
81. Very good. Do you see the answer here?
Yes.
All of you understood the logic here? See,
Yes, sir.
finding the answer is not important. Understanding the logic is important, so that in future you can handle any situation, right?
Yes,
Hope it is clear. Okay, done. So we move on to the next question. Now, can one of you read out again as usual?
So the final exam scores of an institute has a mean score of 74 and a standard deviation of 6.8. The exam scores follow a normal distribution. What is the distribution for the mean exam score of 50 students?
Very good. Thank you, Anurag. So hope our RK sir could have taught you this, how to represent a distribution. Generally, when I write n here, it means normal distribution. Approximately means it is distributed as. X means a variable x. X bar means mean of the variable x. X bar means mean of the variable x. X means a random variable x distributed normally with a mean value of 74, standard deviation of 6.8. If I have to read this, random variable x is distributed normally with a mean value of 74, standard deviation of 0.96. All of you understand how to read this thing, right? Mean of a random variable is distributed normally, right? With central value or the average 74, standard deviation 6.9, something like that. So now look at the question. What are they asking? A final exam score of an institute has a mean score of 74, standard deviation of 6.8. The exam score follows normal distribution. What is the distribution for the mean exam score of 50 students? What is the distribution for the mean exam score of distribution? Do you understand what are they asking us in this problem? Which distribution represents? What is the distribution for the mean?
Yes.
Mean, sir.
Mean means it is in
X bar.
X bar only. Very good. Good observation. So first two only.
Yes, sir.
And the final exam score, okay, it's a mean score of 74, standard deviation of 6.8. The exam score follows a normal distribution. What is the distribution for the mean exam score of 50 students? 1 second. Okay. So the first two, see, what we are talking about is the mean value. What we are talking about is mean value. Mean of the means will approach population mean. Mean of the mean will approach population mean. That is why 74 is here.
Hmm.
Let us say you have 45 mean values. How many mean values? 45 mean values. For the 45 mean values, if you calculate a standard deviation, you will get a value, isn't it?
Yes.
Yes, sir.
What I am talking now is standard deviation of the 45 means.
Oh.
But means or data is not available. But what is available is this standard deviation is available. How much it is available? 6.8.
6.8.
Oh, what is your subgroup size?
50.
50.
50.
Student.
Standard deviation divided by square root of subgroup size. What is it called?
Standard error.
Very good. That is called standard error of mean. So you find out the standard error of mean. Find out the standard error of mean. That will be the standard deviation of distribution of the mean. All of you understand?
Yes.
Standard deviation of the mean is called as standard error of mean. Standard error of mean can be calculated from the standard deviation of the population. Standard deviation of the population is 6.8 divided by square root of n. Can one of you find out how much it is? 6.8 divided by square root of n. (6.8) divided by square root of n.
Zero 0.961.
Very good.
0.9615, sir.
Now, which is the answer? A or B or C or D?
So B.
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 B. Because we need X bar. We are now visualizing the mean. So X bar is normally distributed with the mean value of 74, standard deviation of 0.96. Hope all of you understood this question. Am I correct or not?
Yes.
Yes.
All right. Moving on. Look here. X is normally distributed with the mean value of 80, standard deviation 20, where X is marks secured by the students in the mock test. What is the probability? The score will be between 75 and 85. Do you think you will be able to find out the probability? Suppose you have to find out the probability, will you be able to find out? All of you. As a black belt, will you be able to find out the probability? Please say yes or no. Any idea coming up? Make a try. How can we calculate? See, earlier you remember, we found out the probability from -1 to +2. Yes or no? -1 to +2 we found out. That is
Yes, sir.
in terms of standard deviation. But here, in terms of the exam mark.
Sir, this 75 and 85, maybe I think USL, LSL, and then 80 plus 2 is this size control limit, right side, and 80 minus 2, 78 will be left side control limit. Maybe we can calculate the area under the curve.
Right. So let me help you with the help of Minitab. If you can see my Minitab screen,
Yes, sir.
Yes. Sir.
there is a graph. There is a probability plot. Graph, probability plot. Oh, sorry, not this one. Go to graph. Go to probability distribution plot. Can you see view probability in the last?
Yes.
Yes,
Sir.
sir.
Give OK. Now choose normal distribution. Give mean value equal to 0, standard deviation equal to 1. When mean equal to 0, standard deviation equal to 1, my normal distribution will become standard normal distribution. When mean becomes 0, standard deviation become 1, normal distribution becomes standard normal distribution. Now go to the standard area. Now, what is the area you want? I want area in between 2 points. Let me choose the last one, in between 2 points. Do you remember now? Right? When I choose this one, the gray area is the probability. Right? One line is here, another line is here. So I click that. And also choose X value here. Choose X value. Choose this point. X1 is here, X2 is here. Remember our previous question. What was the X1? -1. What was X2? +2. You remember?
Yes.
What is the probability we calculated? 81%. Am I right?
Yes.
Yes, sir.
Let me give OK. Now Minitab will do it for us. Can you see the 81 coming here?
Yes.
So what I suggest all of you as a black belt, don't struggle too much to find out the probability and all. Leave that job to this Minitab. It's very simple. I'll repeat it once again for you. Graph. Where should I go?
Graph. Probability distribution. plot.
Probability distribution plot.
Very good. Now which one I should choose?
Sir, view probability.
View probability. Give OK. Now here, look here. How many distributions are there? So many are there. You can slowly master. Now it is normal. When I give 0 and 1, it becomes standard normal. Now go to shaded area. I want area between 2 points. What is the option? This is right
Middle,
tile.
sir.
This is left tile. This is both tile. But this is the option we want, the last one. Now -1, -1. Instead of -1 +2, if I give -2 +2, what will happen? Can you make a guess? What will be the area between -2 and +2?
Sir, 68.
95.45.
Beautiful.
95.
I give OK. Can you see 95.45?
Yes, sir.
That's all. Now job becomes much easier for you. You can do it for anything now hereafter. If I give 1.5 here, 2.5 here. Do you think Minitab will give me the probability?
Yes, sir.
Yes or no? Very
Yes, sir.
good. So now, no, now which means you are now ready to solve any problem and find out the probability. Now let me go to the question now for you. Then we will come back here. Now look here, our question. The black, oh, not this one, previous one. X is mark scored by the green belt student in the mock test. What is the mean value?
80, sir.
Standard
80.
deviation?
2.
So this is normal distribution or standard normal distribution?
Normal distribution.
Normal distribution. And you need to find out the probability between 75 and 85. If you are part of this classroom, what is your chance to score between 75 and 85? This we are going to solve it in Minitab, right? You need to give me the inputs. Now I am again with the Minitab screen. Let me go to graph, probability distribution plot, view probability, normal. But what is the mean value?
80.
Standard deviation? 2. Shaded area. X value. What is the mark? Your X1?
Sir, 75.
75, 85.
I give okay. Now what is the probability for someone to score between 75 and 85?
98.76.
How are you saying 98%? If the mean value is 80, standard deviation is 2, 98% chance is there for a student to score between 75 and 85. Clear?
Yes.
Yes, sir.
You can now handle any situation. I have explained it with the mark. You can apply it for product dimension. You can apply it for the what do you call the surface finish, lead time, cycle time, any continuous data, any problem you want to solve, you can find out the probability by using this method, right?
Yes.
So keep Minitab handy so that you can solve a situation. And now another thing, find the quartile Q3 in a random variable with the mean value of 80, standard deviation of 2. Quartile Q3. Very good. Let me try again. 80 and 2. Stat. Basic stat. Okay. So in this case, just a second. Mm. 80 and 2, right? Okay, now I got the idea. Even okay. I think I'm still in Minitab screen.
Yes,
Yes,
sir.
sir.
Very
Sir,
good. So graph, probability distribution plot, view probability. Okay. What is the problem? Mean is 80, standard deviation is 2. Shaded area. Now you have to find out quartile 3. Can one of you tell me what is quartile 3? Quartile
Third
3
quartile.
means, yes, please. Yes.
Third quartile.
Quartile 3 means above that point, 25% area will be there. Am I right?
Yes, sir.
So look here. I am now choosing right tile. Do you see the x value here in the first thing? X variable.
Yes.
If this x variable is quartile 3, area to the right of x value will be 25%. So I click probability. The right side probability should be how much I should give here? 0.25. Now what do I want to know? The x value. So now I give OK. Now what do you understand? Can you see the graph now? The area is 25%. And what is the point? To the right of it, the area is 25%. What is the point value?
81.35.
81.3.
So what is 81.35 called? Quartile 3.
Quartile 3.
Now again, let me show you a few more things. Probability distribution plot. View probability. Okay. Shaded area. Instead of 0.25, let me type 0.5. What is that I'm trying to find out now?
Median, second quartile.
Median or quartile 2. You see,
2.
median is 80. It comes to center, isn't it? Median is equal to mean here. Graph. Probability distribution plot. View probability. Okay. Shaded area. I type 0.75 now. What is that I'm trying to find out?
First quartile.
That's all. So if the mean and standard deviation is known, you can see first quartile is 76.85. Hope it is clear to all of you how I solved the situation, right?
Sir, can you please explain what the concept about the quartile? Q3 is 25%. We should take like that, sir?
Q3 means a point that will divide your area into 75 on the left, 25 on the right.
Okay.
Q2 means point that divide your area into exactly 2 of.
Okay.
Q1 means it will divide your area 25%
Left.
on the left, 75% on the right.
Okay. Yes.
All of you please understand, any point you are choosing, the area to the right of the point is what we call it as p-value. Hope you understood now, no, based on our discussions. So now again I am taking you through the presentation. So all this we have discussed now. A black belt is developing a failure mode and effect analysis in a software development unit. The following ratings were developed for the failure mode due to wrong coding. Okay, severity, occurrence, detection. What is the risk priority number here?
54. Severity
Product of
occurrence to detection.
50.
3 into 2 into 9. 54 is the answer. This is sample size calculation. This problem is related to sample size calculation. Find the sample size for one sample Z test. A situation demands for a Z test. The difference you want to validate is 0.5. Can one of you tell me what is that we generally test in Z test? Mean or proportion or standard deviation? What do we study in Z test? Mean or proportion?
Mean.
Z test is for mean.
Mean.
And the difference in the mean is given 0.5. To validate a difference in the mean of 0.5, what is the sample size? You must achieve power of test of 95%, confidence level of 95%, and the variance in the data is given in the form of standard deviation, which is 0.75. How to tackle this situation? I'll tell you, RK sir has developed a template. You can use it. You can learn a lot from him, right? Or otherwise, go to Minitab. Go to stat. Can you see sample size here? Power and sample size.
Yes, sir.
Power and sample size. Go to one sample Z. Sample size. Do you know sample size? That is what we want to find out. So come here. What is the difference in the mean you want to validate? How much is the difference given?
0.5.
0.5.
0.5.
What is the power you want to achieve?
0.95.
0.95. Is that standard deviation given to you?
Yes, sir.
Yes.
How much?
I think 0.75.
How much? Let me cross verify. Standard deviation is 0.75. Very good. Thank you. You are right only. So 0.75. Let me put 0.75 here. Now I give okay. I think I can give. And now one more thing. Let us go to option also. Significance level. How much significance level you want?
Less than
0.05.
point, less than 0.05.
When I say significance levels of 0.05, what is the confidence level I'm trying?
0.95.
95%.
95%.
Confidence level 95%, power of test 95%, difference in the mean is 0.5, and standard deviation is 0.75 or something. Now I give okay. Again I give okay. Now Minute has developed a curve for me. Now what is the sample size it is suggesting?
30.
30.
Go for it. So if you go for a sample size of 30, the power of your test will be 95%. Confidence level will also be 95%. See here, your y-axis is the power. Can you see 95% here? All right.
Yes.
Yes, sir.
This is how the sample size can be judged. Here. So what do we understand? Sample size depends on power of test, depends on confidence level, depends on the difference in the statistics. Difference in the statistics is 0.5 and the variance in the data. How many factors decides your sample size?
4 factors.
4 factors.
4 factors.
Know the values of these 4 factors, then you come to know about sample size. Otherwise, you know, it is guesswork only. Hope it is clear to all of you. Now, this problem just now we handled. So what is the answer here for this problem?
30.
30.
30.
Very good. The extrusion die is used to produce aluminum rods. The diameter of the rod is a critical quality characteristics. And the specification of the rod are 100 plus or minus 0.5. If it is 100 plus or minus 0.5, do you know how to calculate USL, LSL?
Yes.
Very
Yes,
good.
sir.
The process average is 100.31. What is process average? X bar.
X.
Estimated standard deviation 0.05. Estimated standard deviation 0.05. Now you have to compute CP. Now tell me, have we given a template to handle the situation?
Yes.
Will you be able to use the template? All of you, have you practiced it at least once?
Yes, sir.
Yes, sir.
Please substitute these values in the template. Template will throw away CP as well as CPK. Whatever is the question, you will be able to answer. RK sir has developed, you know, so many template, and I have also given a simple template, one Excel file, isn't it? I have posted. Am I right or not? I have posted in the WhatsApp group.
Yes, sir.
The file is named as Sigma Level Calculator V5. That's the only file I want you to be familiar with. And parallelly, RK sir is giving you a template for each and every tool. So anything which is comfortable, please follow that. And the answer is 3.33. I'm not demonstrating now, right? Because I want to see that no, you move on to RK session next, right? Another few minutes I'll close. See here again, this problem RK has already explained. This we have already discussed in the previous class. Whomsoever attended my last Wednesday class, you might know. The opportunity for error is given, right? How many opportunity? RAM, motherboard, screen, hard disk, Bluetooth, memory slot. Opportunity for error is 6. Number of laptops inspected, 1000. How many defects noticed? 238. Defects, units inspected, opportunity for error. If you feed all these things, do you think our template will give ZST value?
Yes.
Very good. So this is a so simple question. And again, similar problem. The dimension of a particular part should be between 125 and 130. So LSL is 125, USL is 130. Sample of 100 parts. Process average is 126. Variance is 0.25. Can one of you tell me what is variance?
Square of
Square of
standard deviation.
standard
Square
deviation.
of
Variance is square of standard deviation. So convert the variance into standard deviation first, and then you will be able to pick up the answer, right? Zst Zlt and Zst Zst. Because in the template, we need standard deviation, not variance. So take the square root of variance, you will get standard deviation. And this is about MSA, right? Total variation is 0.622. Gauge R&R is 0.599. What is the part to part variation? Please note all of you, total variation equal to measurement variation plus part to part variation. Am I right? Total variation is measurement variation plus part to part variation. So part to part variation is total variation minus measurement variation, right? So apply the equation, you will be able to figure out the answer, right? You can probably go through the recording and practice it yourself. I am only given the hint. Now this is a problem which demands hypothesis testing. This requires data also. That means turnaround time. There are 4 laboratories. Laboratory A, laboratory B, laboratory C, laboratory D. You need to figure out whether any specific laboratory has a significantly lower turnaround time. Tell me which hypothesis testing will best fit.
ANOVA.
ANOVA, very good, right? And they are simply asking you whether there is a significant difference. Look here, assuming data is normally distributed and equal variance, analyze the data and determine is there a significant difference. When will you say the difference is significant?
If p value is less than 0.05.
That's all. You should be able to copy paste the data, conduct ANOVA. If p value is less than 0.05, you can say there is significant difference, right? That you can do it. For a particular hypothesis testing, alpha equal to 0.1, beta equal to 0.05. Alpha equal to 0, beta equal to 0.05. What is the power of test?
D 0.95.
1
1
minus
beta.
beta.
1 minus
That
beta.
is power.
Beautiful. For find a significance level when the characteristics value is not allowed in the extreme and beyond 1.5 standard deviation on either side. Are you able to understand the question? All of you are able to understand the question? Find the significance level if the characteristics value is not allowed beyond 1.5 SD. Let me explain you with the mini tab, right? So I am again with the mini tab. Graph, probability distribution plot, view probability, okay, shaded area, two-tailed, both tailed, right? And X value. Both tail means this one. This side is, first of all, wait. Distribution should be not 80. Graph, probability distribution plot, view probability, okay. Here, normal distribution, I should make it standard normal first, 0, 1. Right, now come here, shaded area, X value, two-tailed. How much they said? Minus 1.5. This side is plus 1.5. Minus 1.5 plus 1.5, okay. Now what is the shaded area?
0.86.
86.
0.8.
So what is the area outside the shaded area? That is outside plus or minus 1.5 standard deviation. Close to 14%. 14% is the level of significance. This 86% is the confidence level. Now you go to your question. What is the answer?
13.36.
36.
Beautiful. 13.36 is the significance level. If you say observation beyond 1.5 standard deviation is not acceptable, not tolerable, then level of significance is 13%. Correlation coefficient is 0.9. The percentage of variation in the response variable explained by the variation in the explanatory variable is. Correlation coefficient is 0.9. Then the percentage of variation in the responsible variable explained by the variation in the explanatory variable is Correlation coefficient is 0.9. Percentage of variation is explained by the variation. The expected variable is 0.9 into 0.9. I think there is some typo error here. So we have to square, yeah, correlation coefficient. If we want to find out the impact, we have to square. So 0.9 into 0.9, how much? 81%, right? All of you understand, because how do we find out the impact a factor is making? R square. R is available 0.9. 0.9 into 0.9, 81%. 81 should appear here. It is not appearing. I think there is a typo here.
So that is like coefficient of determination. R square.
That's called coefficient of determination. Correct. In a two-way ANOVA with one factor at 4 level and other factor at 3 level without replication, what will be the degree of freedom? Will you be able to find out? One factor with 4 level, other factor with 3 level. What is the total number of trials?
12,
12. So degree of freedom?
11.
Very good. In two-way ANOVA with the 4 levels of factor without replication, total degree of freedom. In one-way ANOVA with the 4 levels of a factor. So how many levels? 4 levels. So how many experiments minimum? 4 experiments.
4x.
Without replication means 4. So what will be the degree of freedom?
3.
That's
3.
all. So this is what I just wanted to share. So I stop here and then you can continue with Dr. RK. And you can see this week you have the exam, and exam questions will become easier if you complete all the preparatory exams, and then if you go through our recordings of the Wednesday class and Thursday class, right? And in my opinion, all of you stand a chance to score close to 100 mark, right? But if you want to keep you away from the 100, probably you can miss some certain things, some of the instruction. The instructions are going through all the preparatory exams and then just going through our Wednesday classes where we discussed all these analytical questions. So if you do all these things, you will see your mark close to 100%, right? So over to Dr. RK, all the very best, all the black belts here.
Thank you, sir.
It's not the end.
Thank you.
We are going to continue learning even after the completion of your training program. So we'll see how we are going to meet and all those things, right? RK sir, you can take over.
Thank you very much. Thank you, participants, for giving 5-star for vision excellence. Thank you for accepting my request. And suddenly one has joined now. Who is that? I don't know. Who is that? Oppo. Can you guess who could this be? Who could this? Oppo. Welcome, sir. Oppo. Who are you?
Sir, Mantesh Patil here, sir.
Huh?
Mantesh Patil, sir.
Maushik Patel. So you can name it,
Mantesh.
rename,
Mantesh.
rename yourself, sir,
Yeah, I'll do it.
so that I'll be able to understand, because I'm not able to hear properly.
Yeah.
One second. So what shall we do now? What shall we do? Doubt clarifications. Tell me your doubts. Ask your doubts. Yes. I'll stop recording and then start again. I can't stop, huh? Okay, it's already being recorded. Therefore, there's no need for me to record. Yes, sir. Why don't you come on video, yeah? All of you. All of you come on video. Roshan Kumar, Mantesh Patil. Yes, Roshan Kumar, sir. Welcome, sir.
Thank you, sir.
Yeah, you are supposed to ask me question. I want Roshan Kumar to ask me question. Whatever will be the question, I want him to ask me questions. There's no point in praising somebody. Must put me in trouble. Ask me some questions. What is that? Put me a question so that I'll be finding it very difficult to defend myself. Yeah. In Six Sigma methodology. In Six Sigma methodology. You tell me a situation, narrate a situation where there's a problem. Tell me.
So till now we have discussed the thing related to normal distribution.
Yeah.
So whether some other distributions are there as well, like binomial distribution.
Yes, yes,
So,
yes.
so when actually we check for the binomial distribution.
Okay, okay. Yes, yes. I will take that. Thank you very much for that. Because you all will score more than 90 marks. I think last time itself we have seen that the quiz, right? Otherwise, I'll also give you more quiz on that thing. We will see that quiz also. But this is a point raised for 1 second. I don't know. What we'll do is distribution. One Academy, black belt, and then FB. See here distributions, types of distribution.
Sir, we can't see your screen, sir.
Huh? You are not seeing my screen. Oh God,
No.
sorry.
Not visual, sir.
I'll share it. I'll share the screen. I don't know where to go. Oh yeah. Yes. Yes. Types of distributions only for students. Yes. Is there types of elsewhere? Okay, we'll come back to that. If I don't find that, I will come back to that. I'll come back to that. Remember this regression. Yeah. Black belt quiz. Anyway, we will go back to that because I don't have time for that. Therefore, what I will do is types of distribution. Yes. Are you seeing the screen?
Yes, sir.
Yes.
Yes, sir.
This is about the normal distribution. This is about the normal distribution. This is for population. This is for sample. This is for number of samples, right? Sample mean distribution. Are you able to understand these three? Yes or no? Yes or no?
Yes.
Yes,
Right.
sir.
Now, if it is not following normal distribution, you will know how it is following or not following, right? So we will see this first uniform distribution. You know what is uniform distribution? Constant 1 by b minus a. What is the constant? 1 by b minus a. From the region x is equal to a to b. Are you able to understand this distribution, uniform distribution? Yes or no? You want some meaning?
RK sir, sorry to interrupt.
Yes.
Once your meeting is over, you please
Yeah.
end the meeting from your side, sir.
Yeah.
Right? Because recording is going on, so I'm not exiting the meeting.
Okay.
You
Okay.
please end. It will get recorded. Thank you.
Participants, are you able to understand this distribution? Because I have to share my screen again. I think 1 second, sir. Okay. How do I don't know? I don't know how to write here. No. I have to have types of distribution. I have to find out. Is there a PPT? Yeah, yes.
So just
Yes. Yeah. This particular slide you all know, so I will not go through that. Now this is what we will see. Please go through that uniform distribution. 1 by b minus a, where x varies from a to b. This is x-axis. X-axis the value is a constant. What will be the shape of this uniform distribution? Guess. 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 This is x-axis. It is valid from A to B only. And the probability value is 1 by B minus A. Are you able to visualize this distribution?
Hmm.
Yes or no?
Yes, sir.
That's all,
Yes, yes.
right? It is varying from A to B and the probability is always constant. Anything to occur between A to B is always this much. What should be this value? The total area should be 1. Yes or no? Total area should be 1. Therefore, this height should be, the frequency is 1 by B minus A. So height into B minus A is 1. This frequency into B minus A is 1 because the total area should be 1. What is the probability of occurrence of this and this? Less than A and greater than B? What is the probability of value occurring less than A and greater than B?
Sir, 1 minus 1 divided by B minus A.
No, 0. Here 0. The probability of occurrence is 1 by B minus A only in this region. In this region. Yes or no? From
Yes,
A
sir.
to B only. Clear?
Yes, sir.
Very clearly it is given, no? What is the meaning of x greater than A less than B? This is x-axis. Yes or no?
Yes, sir. Yes, sir.
X is varying only from A to B. Only in this region it is valid. And then the height is B minus A, which is constant. Because A and B are constant, therefore this is the graph. Understood? Clear? And 0 otherwise. If it is not x between A and B, it is 0. The value of this is nothing but value of y. Y is equal to constant. And the constant is obtained by 1 by B minus A. Clear? Yes or no?
Yes, sir.
Give me an example for this, yeah.
Yes.
Give me an example for this. I will give you an example. Yeah, coin. You are tossing a coin. What is the probability of head falling? Tail falling?
50%.
50-50.
0.5. Right? Okay. Now I'll call this as a -1. I'll call this as a +1. So head falling is 0.5. Tail falling is 0.5. Anything between these two falling is 0.5. Right? You take a card. 52 cards are there. What is the probability of anyone getting only one card? 1 by 52, yes or no?
Yes,
What is the probability of getting
Yes, 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 sir.
red color king as something like that?
yes, sir.
Right? Probability of red 9, black 9, odd 9, odds 9. You will say specific card you can mention. What is the probability of getting that? 1 by 52. Yes or no?
Yes, sir.
Yes.
See, it's 152. Right? And 0 also is there. So the difference between this is this. Can you get any other card other than this 52 cards? No. Unless
No,
it is
no.
right, it is not. Therefore, this is 0 here. Probability of getting any other card is 0. Probability of getting any one of these 52 card is 1 by 52. Right? Clear? Understood? Uniform distribution.
Yes.
Now that you know that, it is very easy to find out what is going to occur here. What is going to occur here? Now, we will see the next one. For this, mean and standard deviation formula. The mean is A plus B by 2. Standard deviation is B minus A by 12, root of 12. So this can be derived. A little amount of mathematical knowledge is required. And even otherwise, with common sense, if you spend with me about 1 hour, you'll be able to understand this, right? Okay. And it is written as X variable is distributed uniformly between A and B. Bernoulli distribution. Here, there are only two possibilities. Right, P and Q, probability of head falling, tail falling. Bernoulli is probability of P, probability of Q. P means pass, Q means fail. So one result or the opposite result. Here, it depends upon the X values. The Bernoulli is distributed, the Bernoulli variable is distributed with 1 and comma P. So probability of occurrence of one is P. That is what is one time tossing. That's all. You toss it only one time. So if you toss it more than one time, then this will be the probability. Binomial distribution. Here you are tossing n times. If you are tossing n times, the probability of your success is P. Probability of your failure is 1 minus P. Then if you want to succeed n times out of 100 times, then it is given here. So probability of occurring X times out of n tosses, likewise. NP root of NPQ. This is the standard deviation. This is the mean here. This is variable distributed binomially with n number of occurrences with the probability of success in each occurrence is P. Here it is only one occurrence. Exponential distribution. Here the function, see, please note, what is this column giving? Second column. Tell me what is the second column giving? What is the second column giving?
Formula to calculate.
Huh? What is this second column giving?
Formula.
Huh? One
Formula
second.
to calculate that particular.
What is this second one? Anyway, let me show you this. Now, what is this one? What is this called?
The normal distribution.
This is called distribution. Okay. So
Hmm.
any value to occur, what is the probability? Or up to that value to occur, what is the probability? How do you find the probability of any value occurring? Tell me, what is the probability of any value occurring? Suppose I take this value. What is the probability of this value occurring? This frequency. Yes or no?
Yes, sir.
What is the probability of any? That is, you have to, small difference you have to take. Right? What is the probability of a value occurring, any value occurring up to this point? This area. Yes or no?
Yes, sir.
Right? What is the probability of any one card getting from the 52 cards? 1.
1.
Yes or no? So that is the total area of this 52 cards. Any one card occurring is, any one will have to come, therefore this total area. Right? Similarly here, all these are given nothing but distribution. This is nothing but how the distribution will look alike. This distribution, normal distribution looks like, by uniform distribution looks like, Bernoulli distribution also you can plot, binomial distribution also you can plot, and then exponential distribution also you can plot. So exponential distribution will be like how much? It will be like this. Yes or no? Yes or no? What is this distribution? Parabolic distribution.
Parabolic.
This is exponential distribution. Yes or no? Right?
Yes, sir.
Yes.
Now, then, for this, the mean is 1 by lambda, standard deviation is 1 by lambda. So if you know the mean, you can find out this distribution, right? Poisson distribution. Here, x, mean, and then 0 is the, I don't know what is 0. It is for cumulative and frequency distribution. That's all. So e power minus lambda, lambda power x by factorial x. Mean is given for any value to occur. The probability is given by this particular distribution formula. So the mean here is lambda. Standard deviation is root of lambda here. See here, this is called X is distributed, Poisson distributed with mean lambda. For exponential and Poisson, there is only one variable need to be given, lambda. For here, you need to give two values, here A and B, here N and P. For normal distribution, what you should give? How many values? Two values. What are they?
Mean and standard deviation.
Mean and standard.
That's all. You got it. That is why we say capital N within bracket, mean and standard deviation, close bracket for normal. So for the other distributions, it is like this. For Gaussian distribution, do you know what is Gaussian distribution?
Yes, sir. Normal distribution.
Very good. That's all. And the formula is here. We did not show you the formula. This is the formula here. So for various values of X, if you use 0 and 1, you will get that standard normal distribution. If you give any other mean and any other standard deviation, you will get any other normal distribution. That's all. It is a function of X only, right?
Yes.
And then here, the mean is given by this formula. Standard deviation is given by this formula. And it is given by normally distributed with mean mu and standard deviation sigma. These are all the distributions. So you have got an idea about what are all the distributions. Yes or no, sir? Roshan?
Yes, sir.
Yes, sir.
Very good. Now we will see one by one. Case study. A box contains 100 balls of different colors. Now, ball in color is given. Right? Now, BG, this is the color I have given here. Color I have given. So, what is the probability of my blue getting? I take a ball. What is the probability of my getting a blue color ball?
20 by 100.
20 by 100.
20 by 100. What is the probability of my getting a green color ball?
Same 20 by 100.
What is the
20 by
probability of my getting red color ball?
20 by 100.
100.
So
Same,
now it
same.
is a uniform distribution. Yes or no?
Yes, sir.
Yes, sir.
So this is a uniform distribution. You got an idea, right?
Yes, yes. Now it is clear, sir.
Very good. Right. Now Bernoulli distribution we will see. Tossing a coin. Now what is the probability of getting a head? 0.5.
1 by 2.
So what is p value?
0.5.
0.5. What is the probability of tail getting? 0.5.
Again,
0.5.
So what is the
0.5.
q value? 0.5.
0.5.
Yes or no? Remember,
0.5.
0.5 plus 0.5 is 1.
One.
Total area is 1. This is a uniform distribution. Yes or no?
Yes.
Yes or
Yes,
no?
sir. Yes, sir.
This is also 1. This is 0.5, 0.5. So total is now, so uniform distribution you can see here. Now I will see here case study 3, binomial distribution. Now Bernoulli we have seen, binomial we see. Tossing a coin 2 times, right? Tossing a coin, then what will be the sample space? The sample space will be 4. I will tell you why. First time you may get head, first time you may get head or tail. First time if you get a head, second time you can get either head or tail. Yes or no? First time you get tail, second time again you can get a head or tail. Other than this, there can be no other possibility. Yes or no?
Yes.
So the
Yes,
total probability is 1. One of this will have to occur. Yes or no?
Yes.
So what is
Yes.
the probability of 2 heads occurring? First of all, also head, second also has head. So 1 by 4. Out of total
Yes,
possibilities,
1 by
this is the
4.
only way possible. Therefore, 1 by 4. What is the probability of tail falling both times? Again, 1 by 4.
1 by 4.
What is the probability of head or tail falling? Either head first time, second tail,
2
or
by
either
2.
first tail and second head. Probability of 1 head or 1 tail, 1 head and 1 tail falling is 2 by 4.
2 by 4.
That is 1 by 2. Clear?
Yes, sir.
What is p plus q whole squared? P squared plus 2pq plus q squared. Understood?
Yes, sir.
This is called binomial equation, binomial formula. Why we call binomial? Only 2 terms are there. Right? If I am going to toss 3 times, what I should put? P plus q to the power of 3. If I toss 100 times, I should put p plus q to the power of 100. Anyway, we will see for this year. What is p squared? 0.5 to 0.5 is 0.25, which is 1 by 4. That is what we said probability of this. Probability of two-tail falling is also 1 by 4, which is 0.25, which is nothing but q squared because q is 0.5. Yes or no? And the probability of head or tail falling is 2 times PQ, 2 into 0.5 into 0.5, 2 times 0.25, which is 0.5. That is what we got. 1 by 2. Understood?
Yes.
So this
Yes,
is
sir.
nothing but Bernoulli distribution, which is nothing but binomial distribution, because this satisfies p plus q to the power of 1. This satisfies p plus q to the power of 2. See here. Do you see one thing here, Roshan? Please
Yes.
see here. How does it look? How does it look?
Oh.
Crude normal distribution. Yes or no?
Yes.
Very
Yes.
crude. If I make it 100, it will be perfectly normal distribution. Anyway, I'm going to tossing a coin 3 times. See here, all the 3 times head, all the 3 times tail. So either head and 2 times head and tail, or 2 times tail and head. Right? Okay. First time head, second time head, then tail. First time head, second time tail, second time head. So all the possibilities are given here. So total is 8 probabilities. What is p plus q whole cube? P cube plus 3p squared cube plus 3pq squared plus q cube. So probability of 3 head falling, all the time head falling is p cube. What is p cube? 0.5 into 0.5 into 0.5 is, what is it? 0.125.
0.12.
5 into 5, 25, 25 into 5 is 125. So put 1 point for everything.
0.125.
Right. Similarly, for 3 tail, it is 1 by 8. 1 by 8 is 0.25 because 1 by 2 cube. This is 1 by 2 cube is 1 by 8. Right. What is 2 heads falling and 1 tail falling? 2 heads falling is 0.5 into 0.5. 1 tail falling is 0.5. So 0.25 into 0.5 into 3, which is 3 by 8. Right. Similarly, 3pq squared, 1 tail and 1 head and 2 times tail falling is, this is again these 3. 2 times tail, 2 times tail, 2 times tail. Here 2 times head, 2 times head, 2 times head. So this is again 3pq squared is 3 by 8. And see here, this is now closer to normal distribution. Clear?
Yes, sir.
So what do you mean? Binomial distribution also can be solved by normal distribution. Right? Now, a small business receives on an average 12 customers per day. What is the probability that the business will receive exactly 8 customers in 1 day? Now, this is Poisson, I think. This is Poisson distribution. Right? Because we know the average. Mean. 12 customers on average. What is the probability that the business will receive exactly 8 customers today? Use this. Mu is equal to 12, x is equal to 8. Put it in the formula, you will get this. If you know by experience, hey, on an average, only this much will come. That you will get by experience, right? Then you can use this formula, right? And probability of 9 customers, put 9. So 6.5%. You will normally get very low percentage, right? And this is like this, right? And as
Sigmoid type of curve.
yeah, right? Poisson, right? Now we'll see next. Gun tube failures occur according to log normal distribution with the log mean mu prime and log standard deviation sigma. Please note, I have used log standard deviation, log mean. You know why I'm using log? Tell me why I'm using log. The values are going to be very high. I'm going to deal with numbers, very large numbers. So take log. That's all. Simple. Right? Instead of using 1000, what is log 1000? 3. So you will do calculations with number 3 or 1000? Number 3. So find the reliability for 200 exponential. Also. What is the mean time to failure and standard deviation? Calculations are like normal distribution calculus, right? So what is this distribution? Exponential distribution.
Exponential.
Like this. Transform log x to z score and find out. See, when I consider it a log mean, you get a normal distribution line. Right? This is logarithm, this is frequency here. Okay. So at 200 rounds, logarithm of t minus mu prime divided by sigma prime, and you are getting it. So this is a problem, you can solve it. So you can go through this recording and then understand it, right? Now there are only two cases, either you pass or fail. I think Roshan Kumar, your question has been answered, I think. Hereafter we will see
Yes,
that.
sir. Yes, sir.
Pass fail selection. So events can be numbered, even should be numbered. Because head or tail also I should number. Then only I will have total area 1 and all. Even numbers already exist in the case of marks code. So we don't have to bother. Otherwise, we have to convert this category into number system. That is discrete number system. 0 or 1, -1, 0 or 1, 1 or 2, like that. Event of selection or numbered. 1, event of rejection or numbered 0. Event of selection is numbered 1, event of rejection or numbered 0. So you will have to number like this: success as 1, failure as 0. Yes, events are numbered as 1, no events are numbered as 0, right? So this is the thing. Anything may happen. What is the probability of anything may happen? Tell me. What is the probability of anything may happen? Now tell me, anything may happen, yes or no?
Yes, sir.
Yes, sir.
You are confidently saying yes, yes or no?
Yes, sir.
Then what is the
Yes.
probability?
1, sir.
That's all, right? Probability of anything may happen is 1. Nothing will happen. What is the probability?
0.
0.
0.
Because you have said anything may happen. Nothing also is included in that. So nothing, 0, right? So option A 1, your option A 0. Very good. Now, here, what is this distribution? Tell me. Roshan, you should tell me, sir, what is this?
Normal distribution.
Normal distribution.
No,
Normal.
sir, you should. I said visualization. Why are we given height and why are we saying visualization? Or the heights are same, yes or no? Or the heights are same?
Uniform, sir.
Yes.
Oh,
Uniformity distribution.
Uniform. It is uniform. Yes or no?
yes.
Yes, sir.
Right? You have seen normal distribution, no? Heights are slowly increasing towards the middle. Frequency keeps on increasing towards the middle. That is why I say that you should know what a graph is. That means so far we don't know what a graph is. What is it we are looking in the graph? We don't know. What is the x-axis we are looking for? Just a number. Are we looking for just the number? Tell me, sir. Are we just looking for the numbers on the x-axis? Any layman will say, yes. You use minus infinity to plus infinity. No, we are looking for the evens. We are looking for the evens, not the numbers. For others, it may look like numbers. For us, it is evens. Right? What do you mean by even? A dimension of this to this occur. That's an even. A dimension of only 50 mm occurrence is an even. Right? Only white color balls is an even. Only red color ball is an even. We started up with this, no? Head falling is an even. Card taking a I don't know cards. Otherwise, I will know what is that. Number 3. Three is there. No, 3 card is there. Red color, art in red color 3 is there. Right? What is the probability of a 3 numbered card coming? 4 by 52. Yes or no?
Yes,
Because
sir.
we are just multiplying. Ace 3, art in 3, club 3, and then diamond 3. Right? So 4 by 52. Each one is uniform distribution 1 by 52. So 4 by 52. Yes or no? So hereafter, you should never forget that seeing that we are visualizing. The mathematics convey as visually. I told you, I don't know. Please go through my video. Maths behave like human. I told you many times. It behaves like human means it shies away from us. It changes its color. It changes its shape. It changes it bulges. It becomes lean. It becomes thin. It becomes tall. It becomes short. And that is what we see here, no? The graph. Right? See here, I'll tell you. Oh God. I don't know. Control P. See here. This is the difference, yes or no? One is bulging, one is this. You know the difference between these two. When it changes the shape, you know. Now tell me, what is this? What is the difference between these two? This is shifted. It is like you moving away from me if you don't like me and if I come to your house. Yes or no? You don't like me, I come to your house. What will happen? You'll just move away to the next house. That is what is happening here. This is shifted to here. What does this mean? Mean is shifting. The mean is shifting. It is also behaving like us because it doesn't like your specification. So it goes on its own specification. You want 50 mm diameter. It doesn't want you to give you 50 mm dimension. It doesn't like you because you're not given a good machine. You bought a second-hand machine. How will the second-hand machine will give you the same dimension you want? It is behaving, yes or no? It is behaving in the form of a graph. You must be in a position to appreciate, yeah, then you will believe that God is there everywhere, even in numbers. Thank you. So what is this distribution? You've answered. Yes, this question you answer. RK has attended a written examination. Probability of RK scoring dash is 1. Tell me, what is the option, correct option?
0 to 100 marks.
Very good. Option B.
0 to 100.
Very good. Probability of RK scoring is 0. What is the mark?
Option D.
No mark.
No mark. Because I have to
No
score
mark.
at least 0 mark. Right? Very good. So without doing any distribution, you can find out all common sense only. And with distributions, you can do wonders. That's all. Probability of RK scoring is close to 0. What is that?
No marks.
No marks.
Option C. 50
No,
marks.
option D, you have said no, 0.
Option C, sir, 50 marks.
Huh? Option C, 50 marks. Yes, because the probability of getting 50 marks is only this much. This is close to 0, right? Okay. Now, RK's class has a strength of 100 students. All have attended a written examination. Marks are normally distributed. Average class performance is 60 marks. Standard deviation is 4 marks. Now, tell me which option is correct. Hey, what is the time here?
9:20 only, sir.
Huh?
Option C, population mean is 60 marks and population standard deviation is 4 marks.
Very good. Very good. Very good. Very good. Very good. Very good. Please discuss with others why the others are not correct, right? RK's class has a strength of 100 students. All have attended a written examination. Marks are normally distributed. Average class performance is 60 marks. Standard deviation is 4 marks. Select a student at random. What is the probability that his score will be less than or equal to 60? Tell me. Tell me, you need a calculator or Excel sheet, or you can do it. Tell me that answer. You need a calculator or Excel sheet, or you can do it just like that.
Sir, 0.5.
0.5, that's all.
Normal distributed.
The normal distribution, it is a mean. I have said average class performance is 60 marks. So probability of anybody scoring less than 60 is 0.5, more than 60 also 0.5. Very good. Now, 0.5. Then select the student and random. What is the probability that his score will be 50? Oh, sorry, greater than or equal to 50. You need an Excel sheet or you can do it yourself? First, tell me that you can do it just like that or you need an Excel sheet.
I think we did Minitab.
1 second. I will ask you one by one. Will it be option 0?
No, sir.
Will it be 0.5?
No, sir.
Because greater than
No.
60 is 0.5. So greater than 50 will be greater than 0.5, yes or no?
Yes, sir.
And there is only one value which is greater than 0.5 here, yes or no?
Yes, sir.
Now tell me the answer.
0.89.
Option B,
So,
sir.
you got it, Anurag?
Option B.
Right?
Option
You
B,
don't
sir,
have to
0.8.
use any calculator or all you need to do is smartness. Right? RKs, that's why I said if you pass RKs, you will score 90 marks there, don't worry. Select a student at random. What is the probability that his score will be less than 56? Same way. Do it yourself later, right?
So it will be less than 0.5. Therefore, option C.
Option C, 0.16. See here, right? I use the calculator, right?
Yes.
Okay, I use the calculator. You can use this calculator also. And this is how it is. So this is how to use this normal distribution and do this. I think I'll stop with this. Thank you very much, Roshan Kumar, for asking a question which made me take a class of my liking. Otherwise, normally, if I volunteer this
Thank you,
class,
sir.
nobody will like this class. Right? you force the other participants to listen to this very tough subject. Thank you very much. I think I'll stop recording. I don't know how to. So many things coming here. Hey, I am not able to stop this recording. Yeah.
Sir, already Sukumar sir told me the class will be end. That will be the record will be stopped.
Okay, okay. I think I will end the session. Can I end the session, sir?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you very much. Bye.
Thank you so
Show
much,
me your
sir.
face and go,
Thank
yeah,
you, sir.
because this is the last time you're going to see. Hereafter, I'm not going to see you. You are not going to see me, rather. Because I'm becoming old. Bye, bye.
Yeah.
Thanks
Thank
a
you,
lot.
sir.
Thank you very much.
Thank you, sir.
Thank you,
Good
sir.
night, sir.
Thank you very much.
All
Sir.
the best. All the best. Anytime
Yeah,
you
thank you, sir.
want me, you can come to my website also if required. My website
Okay.
I've given you, vaniacademy.com.org.in.online. Anything you can put, you'll get it. Thank
Yes.
you.
Okay, sir. Thank you, sir. Thank you.
Thank
Thank you
you.
very
Thank
much.
you.